Hello parents. I'm thinking right now that some of you might be looking for a fun activity to do with your kids, maybe perhaps in between the times when you're working with them on the assignments that their teachers have asked them to do. So I thought I'd take care of a problem that I have as a high school physics teacher. Every year when I teach about magnetism in my advanced physics classes, I say some comment like, it's just like those electromagnets you made when you were a kid. And more often, I'm getting entire classrooms full of students who have never made an electromagnet. So I thought I'd remedy that problem right now by making little videos showing how you can make an electromagnet at home with your kids. This activity does require adult supervision because the electromagnet can make the wires that we're going to use get kind of hot. But you don't need a lot of complicated materials. You might have these materials around your house right now. You need a cell here, a D cell. That's what I'm going to use. That usually works pretty well. You need a iron nail or some other piece of iron. This iron nail is going to work pretty good, I think. You need something to tape the wires onto our battery. And so, you know, if you can't fix it with duct tape, it ain't worth fixing. So I have a little duct tape there. And then you need some wire. And this might be the thing that you might have the hardest time trying to find around the house, but a lot of us have little pieces of wire left over from various projects that we've done. My piece of wire is about maybe 2.5 feet long. It doesn't have to be this long. You just want to have enough that you can wrap your nail in the wire and have enough left over so that you can reach the battery and have your magnet be convenient to use. So here's what we're going to do. We're going to take maybe about roughly 8 inches of the wire and leave that open. My wire's already been stripped on the end, so you're going to need to strip off the metal, or excuse me, strip off the plastic covering there so that a little bit of the metal's exposed. And leaving about 8 inches there, I'm going to start at the top of my nail, and I'm going to coil the wire around the nail as closely spaced as possible. The formula that I try to teach my advanced physics students involves how closely the coils are spaced, and the closer together they are, the more coils you have per inch or per meter, the stronger the magnetic field that we're going to be able to make is. And so we're going to coil them really close together, make sure they're not on top of one another. Just coil them as close together as you can get them until you get down to the end of the nail. And once you get down most of the way to the end of the nail, you don't have to go all the way to the very end. And you can leave then enough of the wire so that you can get back to the battery. So now I have the nail wrapped in my wire, and I'm going to duct tape my wire to my battery. So I'll go over here. You don't need much duct tape, just a little piece of it, and you can use any kind of tape, of course. Duct tape works really well, but electrical tape if you have some, even packing tape. Be careful those, as I said, this can get hot, and so if it's something that can melt, you probably don't want to use that. But we're going to duct tape the positive terminal of the battery is usually the one that you want to duct tape down firmly, so you can kind of leave that in place. That's not going to move away. And then this one, this is going to be where the contact we're going to make, where we're going to touch it and then maybe let it go so we don't overheat our battery. So I'm going to put the duct tape on kind of loosely over here, and then I might put it down and make contact there. Be careful on this part, like I said, because this can get kind of hot, so be careful when you touch that. This needs to be done with supervision. And so this is your electromagnet, and you can see that it is a magnet. It will pick up things that are magnetic, and so here is a steel paper clip, and my electromagnet will pick it up. And you can see that if you just break this connection here, well, it retains some of its magnetism. Steel will do that because steel consists of iron, and iron is one of the three elements, the three metals that can become magnetic and remain permanent magnets. Other metals, a lot of people think that magnetism works with almost every kind of metal you can have, but it doesn't actually. Here's a piece of aluminum. Let's see if it can pick up the aluminum with the electromagnet. And no, it doesn't do anything with the aluminum. Here is a compass, and you could use this to teach your kids about how a compass works. I'm kind of holding it at an angle here, but you can see, even though I'm holding it at an angle, the electromagnet actually does move the needle of the compass, even though the compass is kind of scraping against the side of the housing because I'm holding it on here. So a little fun activity to do. You can teach them a lot about magnetism. Remember, this is how Einstein got started. His dad gave him a compass one time, and that started him on a lifelong interest in figuring out how forces like that worked. Please remember to only keep your electromagnet connected when you're actually using it. As we said, the wires can get hot, and it can also drain your battery fairly quickly. I'm thinking about doing some more of these videos if I can think of some topics. So if you have some comments or you would like to suggest a topic, go ahead and contact me at one of the ways you see below. Thank you.